Sir, I have a doubt in lab.
Doubt in lab.
Yes, sir.
Okay. So what is your doubt?
When we say that the input signal should not be attenuated and choose a big capacitor, so how do we decide on how big the capacitor should be?
In week 1 or week 2 experiment?
Week 2.
Week 2 experiment. Let me check. This experiment I don't remember. Give me a minute. Single-ended differential input converter and PWM modulator.
Yes, sir.
Okay. So, which capacitor you are asking the C in?
Oh, yes, sir. C1.
Okay. C1 or C in the circuit? I think C in. You are talking about the C in internal capacitance. Okay. So basically the value of capacitance, if we have, like for example, if we have a large capacitance. Okay, so what is the meaning of large capacitance is that if we have a large capacitance, so that means the like for example, if we have a large capacitance, okay, I just share my screen. Yes, can you see my screen?
Yes, sir.
Okay, so basically if we are talking about, like for example, this is our capacitance. Okay, this is my input voltage that I apply V in, and we are getting the V out. So if we say that V out should be approximately V in, how is it possible? Like for example, I am just denoting one resistor also. Okay, so V out is just approximately V in. So that means the V out is basically the voltage drop across the resistor. Okay, and this particularly voltage will be approximately V in. Then when we say that Vc is almost 0. Okay, because V in is what? V in is equal to Vc plus Vr, or Vr is, we know the V out, so Vi is equal to Vc plus V out. So if Vi is equal to V out, that means the Vc is approximately 0. Now if Vc is approximately 0, the voltage drop was approximately, this one is 0, so that means the impedance is 0. Okay,
Yes, sir.
and what is the impedance of the capacitance is 1 by Cs. That is approximately 0. That means we can say the C is approximately high or infinite. Infinite, or we can say the high. Okay, so that's why if the capacitance value is high, so the drop across that one, the impedance of the capacitance part will be the minimum, and if it is a minimum, the voltage drop across this particular capacitance is minimum. So the input that we apply at the input side, we are getting at the output of the capacitor point. Okay, now if you go with the circuit part, so this is your circuit. Okay, now it is a V. So if we apply the VIA input, okay, if you apply the input, so we are assuming that the maximum voltage will be going as a V in A plus terminal, or this dot between the capacitor and the resistor value. So the voltage drop across capacitor should be minimum. Okay,
Okay, sir.
so that's why we just ensure that if capacitance value is high, we are getting a
In practically, how do we choose, sir? Like microfarad, picofarad, nanofarad, what?
uh, if we are talking about, so generally what we do is that if we are talking about the capacitance, so capacitance value is in microfarad. Okay, if we are talking about the electrolyte capacitor, so the electrolyte capacitor is always in a microfarad range. But if we are talking about the ceramic capacitor, that particularly capacitor is nanofarad range. Okay,
Okay, sir.
so we mainly prefer, like for example, this is used for the input point. So this type of capacitor is the electrolyte capacitor. Okay, there are if you are talking about, I don't know, you are remember, you aware about that the electrolyte and ceramic capacitor or not?
Yes, sir.
Okay, and what is the use of electrolyte and ceramic capacitor?
I know that there are different types. I don't know the use, sir.
Okay. So basically, the electrolyte capacitor, where it is required to store the charge. Okay, so generally for that particular purpose, we are required the electrolyte capacitor, and where we provide the high impedance. Okay, we are generally use the ceramic capacitors. Okay,
Okay, sir. Okay.
so
Okay.
ceramic capacitor is generally in the nanofarad range, and the electrolyte is mostly in the microfarad range.
Okay, sir.
Okay. It is mentioned. It is a coupling capacitor. Okay, VCM by using the coupling capacitor. So coupling capacitor is mainly which type of coupling capacitor we are using. Okay, so you can check in the nanofarad range. I think that is okay. Okay, now we go with the weak 9 content. So weak 9 content is basically mainly focused on the charging subsystem. Okay, charging subsystem. So if we are talking about the implementation of on a software platform, and basically designing on a hardware part, so there are lots of variations are there. Okay, So if we design any system, so basically the first challenge is that we have to define the chip selections. Okay, like similarly for the example part, if we are talking about you are doing the experiment, okay, and in this particularly experiment you are using the op amp. Okay, some of asking me that can we use the 6004, or someone is saying that 741 or LM358. Okay, there are lots of operation amplifier are available in the market. Okay, but why we choose the 6004 operation amplifier? Any idea? If you design this particularly circuit with the 741, with the 358, with the 6004, with every operation amplifier you are getting almost same output. Okay, then why we go with the 6004? 6004, or we can say the range is 6001, that is the same family. 6002, same family. Okay, so why we go the 6004? Why we don't go with the 741 and 358? Any idea?
Sir, because they'll take less current.
Yeah. Okay, so first thing is that less current.
And 741 generally operates between plus 12 and minus 12.
Yeah, okay, 741 is a dual supply.
But we don't have this dual supply.
Okay, whereas 358 and 6004 oblique 6001 oblique 6002, that are the single supply, and these are the single supply. Okay, any other difference? It is a dual and quad operation amplifier like this one also. Some one IC has the dual operation amplifiers, one is a quad operation amplifier. Is it? It is the one difference also. Okay. Now the third thing is that the main important thing is that when we choose a IC, so first of all identify that which IC is more reliable. IC is which IC is reliable or stable? Reliable or stable. What is the meaning of this reliable and stable? Is that if we design a system with the 741 or 358, okay, may be possible that you even don't know that after 2 or 3 hours it will be working or not. Working or not. Okay, whereas 6004 is more reliable. Clear? Now, along with that, if we say, if we go with the simulation only, you can simulate your experiment 1, 2 with the 741, with the 358, with the 6004. Okay, any IC, any operation amplifier. Output is same. Output is almost same. Because in the simulation part, there is no limitation. If you design with a 741, in the simulation you provide the two voltages plus 12 and minus 12. You can provide it. Okay, no issue with that one. If the basically it is a dual supply, we can use multiple operation amplifier for a complex circuit. No issue with the simulation part. Okay, but similarly, when we go with the hardware implementation, So we have to convert a 240 volt into the 12 volt. Now with the 12 volt, we generate a minus 12 volt also and use this supply for the as a supply voltage. So this is the limitation. Second, if your circuit is complex, designing is also a problematic. Designing is problematic. Okay, so on the simulation there is no limitation, but when we go into the implementation part, when we go with the hardware designing part, there is a lots of the problem. So when we are going to design a system, when we any system, not any particularly specific system, when we are going to design any system, the chip selection is very important. The chip selection is very important. Second is the problem is the chip integration. Okay, a simple example is that you have to connect your Apple laptop with HDMI cable, HDMI projector. Is it possible directly? Is it possible directly? No, because your Apple laptop doesn't have the HDMI port. Okay, don't HDMI port. Okay, this Apple laptop only C type port. So now you have a HDMI projector where the cable input is the cable port is the HDMI, and your Apple laptop where we can only connect the C type. So in between them we required a interface C type to HDMI. Okay, and after that you just connect your projector. Okay, this is a simple a this is a I am taking as a system, but similarly scenario will be happening when we are going with the implementation part. Okay, other example is that your some sensors or basically the sensor chips will be working on the TTL logic family. TTL logic family, where other will be using the RS232 port. So what we do, we required a interface. Okay, we required an interface, and that particularly TTL to RS232 connector. Okay, one more example if you are talking about, I think you are aware with the Arduino microcontroller. Any one of you?
Yes, sir.
Okay, so what is the requirement of the Arduino? Why we directly initially the 8051 controller is available? Initially 8051 controller is available, then why we switch to the Arduino? The problem is 8051 interfacing with laptop directly is not possible. Directly is not possible. You have to require a 8051 burner. With the help of this one, you write your code into the 8051. Okay, and that particular code is available in your laptop. Okay, so you interface your laptop with the 8051 burner, and the 8051 burner is interfaced with the 8051. So basically, in between your laptop and your 8051, there is a one burner is available. Okay, Arduino we can directly interface with laptop. So what is the benefit of this one? If I want to change a code at any point, so we can directly change the code and upload it on a controller. Okay, so with any basically the two things, that is the chip selection is important, and second we have to check the chip integration. Okay, these two things. Now the chip selection and chip integration will be dependent on 6 different parameters. First, performance. Second, weight. Or we can say the budget. Okay. Third, reliability. Okay, reliability. Fourth, power consumption. Packaging. And last one is the form factor. Okay, so these are the main important parameters. Along with that, there are lots of other parameters also, like for example is the availability, scaling. Okay, but we can avoid these particularly parameter, that is dependent on the market situation. But these are the main parameters. On the basis of this one, we identify that which chip we want to select, how the integration is possible, if the integration is possible or not. It is, if I use particularly chip, but that chip is not interface with the uh, basically the requirement. One more thing, if you remember that have you seen any mobile phone that is having a RAM of 4 GB, but it has a internal storage space of 256 GB? Any idea? Have you seen any mobile phone whose a RAM will be 2 GB or 4 GB, but internal storage is 256 GB? Yes. Have you seen any mobile phone that is available with the Android 1, Android 2, 3, older the Android version, but with they have the space of 256 GB, or they have the RAM of 6 GB? Or maybe if you are talking about the laptop, so any particular laptop that is available that is working on the basically the core to dual processor, but they use the RAM of 8 GB, 12 GB.
Maybe expandable memory can be there.
Expandable, but there is some limitation. How much you can expand that one? Okay, with the dual core processor, you can't connect a 8 GB or 16 GB RAM. Okay, you can't connect a 8 GB or 16 GB RAM. This is the limitation of that one. The limitation is what? Integration part. Okay. Now, if we are talking about these 6 parameters, first is the performance. Performance is basically how my chip will work. Okay. How I can charge my device, how much time it will be taken to charge my device. Okay. The performance is slow or fast. Basically, we say the response. Response is slow or fast. Okay. Then basically that these things will be define the performance of my device. Okay. Second, if you are talking about the rate or budget. So is it a my device is budget friendly or not? Budget friendly or not? Like for example, we have a two mobile phones, M1 and mobile phone second. Okay, both have the same features. Same features. The price of this one is the 20K. The price of this one is the 40K. Okay, same company, everything is same. Okay, almost same features. One costing is the 20K, one costing is the 40K. So which you want to prefer? Or we can say that two different companies with the same mobile phone, everything will be same, the performance will be same. Okay, one will be available in a 20K in the market, one will be available in the 40K in the market. So which you want to prefer?
20K.
20K. Basically, because when we go with the when we develop any system and when we go to the market, because if you develop a system, the requirement is that that particular system or basically that particular product will be available in the market. This is the first requirement. Second is that if it is available in the market, so your market will be for basically there are the lots of customer are available in the market that purchase your product or system. Okay, now if you want that every customer will purchase your system, so you have to maintain that your performance is good as well as your rate will be the compatible with that. Okay, so everyone will go everyone will buying to purchase your product, so the market will be developed. Okay, if the costing is high, if the rate is high, but the features is same with the some other company, so no one will be going to recommend your phone. Okay, if in a simple example, if you are aware that one initially the company is the MI, okay, that is a Chinese company. Okay, now it will be Redmi. Okay, the company should change the name, or basically there is a difference between the MI and Redmi. Yes, Any idea? I think everyone purchase the mobile phones to search out on the Google, or basically there are lots of shopping sites. So any difference between the MI and Redmi? Student, please speak up. Any difference between the Redmi or MI? If you know, just tell me. If you don't know, just tell me that, sir. No idea. So any difference between the MI and Redmi?
No idea, sir.
Okay. Any other? No? Okay. So basically we say that the Redmi is basically the branch of MI. The company is not same. Okay. The costing of the Redmi phone is higher. The costing of Redmi phone is higher. With the same features, other particularly companies are available in the market. They provide their mobile phone with the same feature at a lower cost. So what they do, basically MI company create one more branch of Redmi, where they use the same where they use same application, where they use same features, but with lower quality. Okay, so the difference between that is that the costing is lower. The simple idea is that everyone now, if you are going to purchase a mobile phone, or everyone says that there is a 200 megapixel camera. Okay, and the particular 200 megapixel camera phone is available under 20K. Okay, 200 megapixel camera available with the 20K. Now you capture that picture with the 200 megapixel camera. Okay, and compare with the high range that is available with the 15K or 20K, or basically the Apple 12K 48K megapixel camera. So when you compare the picture, you just see the difference. What is the difference between them? So company will be demanding that your mobile phone will be having a 200 megapixel camera, but the quality is down. The lenses quality is down. Okay, so that's why the costing is down. Okay, to compete in the market, they just develop a 200 megapixel camera. Now if we use this 200 megapixel camera in the MI, they have to maintain the quality of MI, so the price is higher. If price is higher, so they can't go into the market, because no one will buy their product. Okay, no one will be buying their product. Okay, so this is the basically difference. Okay, so the budget is very important. Okay, now if we are talking about the reliability, we can relate this reliability as a durability. If you purchase any mobile phone with a lower budget, they will basically durable for 1 year or maximum 2 years. After that, they will hang down. Okay, there are lots of the issues will be happening. Whereas if you purchase a Apple phone, so you can go with the 5 years, 6 years without any tension. Okay, so the reliability is the basically durability. Now this durability is mainly dependent on the charging part. Charging subsystem. Okay, if you design a system with the 4 GB RAM and 128 GB memory, so it will be maintained. Either you are using 2 years, 4 years, 8 years, doesn't matter. Okay, but the problem is that after sometimes your battery will basically discharge faster as compared to previous. Your battery is not fully charged. Basically, your phone is heat up. Okay, so basically these are the issues that are available when we are going to the durability part. So these all will be focused on the charging subsystem. Okay, so if we are talking about the durability, so first thing is that my battery, discharge behavior, my battery charging time, the phone heat up. After 2 years, your mobile phone Bluetooth is not working. So what is the reason of that one? Maybe the issue in the Bluetooth. And what are the issues that will be having? Because nothing will be going from the outside. The only thing is that your charging subsystem will provide the higher voltage, so your Bluetooth device will be damaged. Basically, it will provide the lower voltage, so that's why the Bluetooth subsystem will not getting a complete accurate voltage. So that's why it is not working. Okay, so two reasons are there. So phone heat up. Then after that, if you are talking about the subsystem failure, this is also the reason of the because of the charging. Okay, any subsystem will be fail because of the charging subsystem. Okay, so power consumption is also the part of charging subsystem. Okay, if charging system is appropriately working, your power consumption will be maintained. Otherwise, it will be taking the high power consumption. So because of this one, the heat up, and due to the heat up, it may damage. Okay, so power consumption is somehow related with the charging system. Other particularly is the packaging. Yes, how you package that particularly, and form factor. Okay, that particularly form factor we will discuss in the later part. Okay, so these are the performance parameter, basically design selection parameter, or basically chip integration parameters. Clear? Any doubt?
No, sir.
Okay. So if we are talking about for any system, the charging subsystem is very important. Okay, so charging subsystem is very important. So we discussed initially the charging subsystem. I think you all have a mobile phone with the fast charging. Yes, I think you have. Okay. So have you noticed when you are charging your mobile phone, have you noticed particularly pattern? I don't know you noticed that one or not, but I notice in my mobile phone is that initially from 0 to 10%, okay, it will be charged slowly. Are you getting the same pattern? I don't know. Okay.
Yes, sir.
Now after 10 to around 85%, it is the fast charging. 10 to 85%, it is a fast charging. And again, after 85 or somehow it is around 90%. I am not exactly sure about what percentage. Sometimes it is 80%, 85 or 90. Okay, so I am just taking the any particular range. Okay, and after that 80 or 85 or 90%, again it will be go to the slow charge. Okay, now if you have an Android phone, there is an application of battery. I think battery status, like battery charging status. There is an application battery charging status. Okay, this is the live. After that we with the go with the charging pattern. So when I'm going with that battery charging status, so 0 to 10%. Okay, my voltage and current, mainly the voltage will be increasing higher. Okay, voltage will be increasing higher and current will be increasing slow. Okay, so that's why 10 to 90% the charging is slow. Okay, now from 11 to 80 or 85 or 90%, voltage is almost constant. Okay, and current, it is increasing. Okay, now after 80 or 85 or 90% to 100%, your voltage is increasing. Your voltage is increasing and current is minor change. Okay, color in minor change. If the value is around, it will be increased from 3 to 3.5, and here it will be increase. My mobile phone has a 1000% 5000 mAh battery, so 0 to 496 mAh. Okay, after that it will be increased for 496 to 4300 mAh. Okay, and in this range it will be go from 3.5 to 3.68 volt. Okay, and after that it will be increased from 3.68 to the 4.2 volt, but the current is 4300 to 5000, and not exactly 5000, it is a 4920 4920. Okay, so this is the pattern that I observe. Okay, second thing is that if you are talking about the fast charging, so what is the meaning of fast charging is that the battery power is increased. Okay, like for example, if you are talking about there are the 20 watt charger, 40 watt charger, 80 watt charger, nowadays 100 watt charger. So basically these are the fast charge, 80 watt and 100 watts. Okay, so basically if you see the difference between the slow charging 20 watt and fast charging 80 and 100 watt is that the voltage is constant. Okay, voltage is constant. Either it will be the 12 volt or 5 volt. Okay, you can check from your adapter if you have any particular adapter. So either it is a 12 volt or 5 volt. Now, if we are talking about the high power charger, so basically the current value is high. So in this case, the current value is around 1.7 ampere hour. So if we are talking of the 100, so it is around 8 ampere hour. So basically, fast charging is only applicable for increasing the current part, not on the voltage. Okay, because voltage is constant. Voltage is constant. We are using the basically transformer, then regulator, rectifier, then regulator. So it will provide me the constant voltage. So my voltage is constant. Okay, my voltage is constant. Now if you are talking about the fast charging, so basically the current will be increased. So similarly scenario is that if we are talking about the fast charging point, that means the current value will be higher. Okay, so this particular range where the current will be increasing very rapidly, it is called the fast charging case. Fast charging case. Okay, now where the voltage value is increasing, we are saying the voltage charging case. Okay, and that particularly will be conditioned before the fast charging, so we call the pre-charge. Pre-charge. Yes. Okay, pre-charge case. So there are the three different cases. So if you are talking about the charging subsystem, so there we have a three particularly scenarios. Initially the pre-charging is done, then fast charging is done, and last one is the constant voltage charging is done. Voltage charging. So we can say the constant voltage charging because voltage I already told it is we are using the rectifier, so it is a constant voltage charging. Okay, any doubt? After that I think the yes. Okay, so I will go with the which is the reference voltage. Now this is the V in, V out. This is the RF, R1. Okay. Now this we are taking an example. That example we can take. Okay, for example, I am taking example of my mobile phone. Okay, and this particularly V out is connected with the LCD. LCD or LED screen. Okay, any doubt? This particularly will be connected with the battery. Okay, now initially my battery is 4.2 volt charge. My battery is 4.2 volt charge. What we are getting on the LCD screen? It is a basically non-inverting amplifier. So it is a 1 plus RF by R1 time Vref. It is a V out. Okay. Now we assume that RF is 200 and R1 is 100. So 1 plus 2 divided by Vref is equal to V out. If Vref is 4.2 volts, so 1 plus 2, 3 multiplied by 4.2, so that is 12.6 volt is the V out. Okay, 12.6 volt is the V out. Now, for my screen, for my LCD screen that will be working for a longer part, they require that if the output voltage is greater than 9 volt, it is a working properly. But if it is a less than 9 volt, the LCD screen will not work. The LCD screen will not work. So, my battery will provide me the 4.2 volt. Now, after the uses, my battery will be start reducing. Battery voltage will be start reducing. So 4.2 volt V bat, we are getting a V out is 12.6 volt. If we are taking the 4.1, it is a 12.3 volt. If it is a 4 volt, it is a 12 volt. If it is a 3.9, we have a 11.7 volt. If it is a 3.5, we are getting a 10.54. Okay. If it is a 3 volt, we are getting a 9. Okay, but if we are getting a 2.94 volt value, so we are getting a 8.7 volt. Now in this scenario, what will be happen? In this scenario, what will be happen? We required V out is 9 volt for on LCD or LED screen. Mobile screen, we can say the LCD, not LCD, LED required for on mobile screen. Now in this case, my mobile screen is off. Screen is off. Okay, but we can say the battery is not a completely zero. Not a completely zero. So now what will be happen? First thing. Second thing, if my battery LED screen will be working on a 9 volt and if you provide a higher voltage to them, so what will be happen? There is a chances that is due to the higher voltage, the device or basically the particularly LCD screen component will be the heat up and after heat up it will be blast. Okay, so two possibilities is there when battery has a 2.9 volt, my mobile screen is on. Oh, mobile screen is. And second case is that when we have a 4.2 volt, my mobile screen voltage is higher than the required voltage. So chances of heat up. Okay, so this is the one problem that may arise when we use this operation amplifier for the internal component. Okay, this is the first problem. Now second thing is that can I use my basically the capacitor as my mobile phone battery? Okay, so similarly if I say that we have a this battery voltage, we have this resistor, this is my output voltage, this is the capacitor. So can I use that particularly capacitor, because capacitor stores some charges, it has a voltage VC. Now can I use this VC as a V in? Okay, so I think you are aware with the equation. So V0 is equal to V final plus V initial minus V final 1 minus e raised to power minus t by RC. You are aware this formula?
Yes, sir.
Okay. Okay, because when we provide the voltage, when we connect my battery with the particular this one, so initially the capacitor voltage is zero. Okay, so we say that in this circuit the battery voltage is there, but after a certain period of time my capacitor will be charged. Capacitor will be charged. Okay, so some voltage drop with the across the resistor and remaining voltage will be stored by the capacitor. So the final voltage of this circuit will be different from the capacitor voltage. It will be the somehow in the form of battery voltage. Okay. So if I put it as here, so it is a V in plus V battery. Initially the voltage is the battery voltage and finally the voltage is the capacitor voltage. And 1 minus e raised to power minus t upon RC. This RC is the time constant that will be decide how much time it will be taken to charge and discharge the capacitor. Okay, to charge and discharge the capacitor, because capacitor will be charging in this way. Capacitor will be charging in this way. So initially they have the constant voltage. After that, the particular voltage will be increased. So this is my final voltage. V final. Okay. So this time constant will decide that how much time it will be taken to charge, or can I use this basically this capacitor as a battery or not. Capacitor as a battery or not. Like for example, if our time constant is very slow, that means it will be suddenly sharply charged and discharged. Okay, sharply it will be charged and sharply it will be discharged. So we can't use that capacitor as a battery, because we required a battery that will be long lasting for a longer duration. Okay, if I use a battery, so my expectation is that my battery will work for a 12 hours, 24 hours, 28, 30, 34, more than that one. Okay, and if my capacitor will hold the charge up to the 20 or 24 hours, so I can use that capacitor as my battery. But if capacitor will be charged in 1 minute and capacitor will be discharged in half minute or 2 minutes, so I can't use that capacitor for a battery purpose. Okay, so this particularly will be dependent on the RC time constant. Where? Now, along with that, I think the professor discussed some current equation. And
Sir, are capacitors really used as batteries in cell phones?
yeah, so not in cell phone, but at the place where we required a less voltage. So at that place we use the capacitors.
Okay, sir. So in
Okay.
burner phones, they use capacitors?
I think you heard about the supercapacitors.
Yeah, just names, sir. I don't know much
Okay,
about.
supercapacitor. Basically, the supercapacitor is a type of capacitor, but that will be used to store a voltage. Okay, but that will be used where the voltage will be around 2.5 or 3 volts will be required.
Okay.
Because if we see that Q is equal to CV, Q is equal to CV. If we increase the voltage, we have to increase the charge. Q will be increased to maintain to basically store that charge, or so we required a size will be increased. Okay, so if we want to store a 5-volt battery, so our charge or capacitor will be increased. Okay, so generally life in our neck bands, okay, in our that particularly part we use the super capacitors. In our earbuds where the size is very less, so the benefit of the super capacitor is that their size is very less and they can store a voltage for a longer durations.
Okay, sir.
Okay, so we use that particularly capacitor as a battery. Okay, but all depends on how much time. Okay, according to this particularly will be done with the help of all calculations. If you use a capacitor, the capacitor, like for example, if I am using a capacitor in a earbud, okay, and that particularly capacitor will be um, working for only the 1 hour 30 minutes 40 minutes, so it is not a compatible. Okay, so our capacitor we have to maintain that it will be store the charge for a longer duration. Now if we store the charge for a longer duration, we required a size also. Okay, so one is the how much charge it will be stored, how long it will charge it will be stored, and what is the size of that. Okay, so on the basis of these three parameters we decide that capacitor is used for the battery or not. Okay,
Okay.
now I think the professor discuss. Any idea what the professor discussed this week? I think the band gap reference voltage is also discussed in this one. Yes, one more thing that discussed with the profile, charging profile that discussed by the professor, that we have a three particularly conditions. One is the pre-charge, one is the and one is a constant voltage charge. Okay, so initially if you are talking about the pre-charge, so like for example we have a battery voltage. One more thing I want to confirm is that I think in your home you are using the AA, AAA chargers. So sometimes you see that your basically AA and AAA charger is not working. Okay, AA, AAA charger that you are using in your device, that is not working. So anyone try to find out that what is the voltage when this particular AA or AAA charger is working or not? Yes, anyone try that what is the voltage within this
No,
particularly?
no, sir.
No?
No.
Okay. So I think you have a multimeter with you. So just try to measure that what is the voltage that your AA and AAA charger that is fully charged and that is not charged. Okay, just try to this one. Uh,
Oh, what, sir? What, sir? Come again.
Basically, you have a multimeters with you.
Yes, sir. Yeah.
Okay, so just try to measure the voltage with the AA or AAA any particularly cell you can take. You have to measure the voltage that when the basically your battery will be fully charged and
Okay.
after the use of that one the battery is discharged.
Oh, okay, sir.
Okay, just measure the voltage of
Okay,
that
okay.
one. So the thing is that when your voltage, when we say that my battery will be discharged, basically the battery voltage is zero. So exactly it is not. Okay, if we are talking
Mhm.
about the we have the AA charger used for some other some particularly part and that will be not providing me the voltage, so that doesn't mean that this particularly AA charger is having a zero voltage. Okay, so anytime when you check it either in the charging or in discharging mode, it will be not having a zero voltage, it will be maintain some voltage.
Okay, sir.
Okay, so that's why if you see the graph here, so particularly it will be not a zero voltage, because if the battery voltage is zero, so it is quite typical to charge that one.
Oh, okay. So,
Okay,
which means that we should not.
voltage is not completely zero.
Okay.
The meaning is that one. Basically, if you see that sometimes you own your car battery and it will be completely fully discharged. Okay, when it will be fully discharged, when you going to start it, it will not start. Okay, it will not start. Why? Because it is a zero. So recharging or basically charging on the cell of the cell is not possible when your voltage is completely zero. When your voltage is
Okay.
completely zero. Okay, so it will be maintain a voltage. Like for example, if your pencils have a 1.5 volt or 1.6 volt, so when it is discharged, it will maintain a 1.2 volts. Okay, it will maintain a 1.2 voltage. But the thing is that due to internal resistor, the resistor value is high, so it will be current is zero. I is equal to V by R. So basically the resistance is high, current will be zero. And if the current is zero, it will not provide that current or voltage to the external circuit. So that particularly cell will be damaged. Okay, cell will be damaged. Okay, so that's why if you see in the basically the professor discussed one thing is that it will be not taking the voltage will be zero. It will be taking the battery voltage with the some initial voltage. Okay, either 1.2 volt, 1.3 volt, anything. Now in the pre-charging, it will be increase very less. Okay, again in the fast charging, it will be increasing faster. Okay, after the constant voltage, it will be almost constant and approach to the 100%. Approach to the 100%. So this is the profile with respect to time period t. Okay, so with this we have three particularly parameters, 3 or 4 parameters is the I fast charging current. Second is I term recharging. Sorry, I term charging. Then third is the I pre-charge. Okay, these are the three current. Okay, these are the three important parameters. Now, fast charging, already told you that when we are going with the fast charging state, how much current it will be provided. How much current it will be provided. So, if I draw the one more graph here with respect to the current. Yeah. So, this is the battery voltage when we are talking about the current graph. Okay, so this is with respect to the time period. Okay, so initially in the pre-charging condition, we required a minimum current. We required a minimum current. So we are taking that we require this minimum current because voltage and current will be increasing or very less. Okay, voltage and current both will be increasing very less. So if you see in the graph, only this much voltage will be increasing. When you see in the graph, only this much voltage will be increasing. So this is the V increase. Okay, and this is the I increase. Okay, so in the pre-charging condition, voltage and current will be increasing very less. Now, second is when the fast charging will be applied. So we have to provide a maximum current. So we have to provide a maximum current. Okay, so this is the I max, maximum current. Okay, and that is the I minimum. And that particularly due to this I max, this particularly is the fast charging condition. Fast charging condition. Okay. Now, when it approaches to the fast charging point, now after that, the required current is reducing. Okay, the required current is reducing. So it will be reducing. It will be reducing. The required current is reducing. The storage current is not reducing. It is talking about the current profile. So the required current is reducing. Okay, so it will be reducing. Now, after a certain time period, after a particular certain level, we can say the current termination is done. So that means my battery is full charge. Current termination. So it is called the I term, current termination. Okay. What is the requirement of termination current? Any idea?
Requirement means what, sir?
Why I term is important? Termination point is important. Why termination point is important?
It will heat up otherwise.
Yeah, basically, if you are aware that either 10 or 15 years ago, when you plug your charger in a mobile phone, after your battery is fully charged, the current will be flowing from that. Okay, and that is a problem. Due to this one, your mobile battery will be basically blast. Okay,
Yes, sir.
it will be heat up, it will be blast, or it will be damage. Okay. Now nowadays, if my phone is charged and I just plug my phone in the power, so no current will be providing to my to mobile phone. Okay, due to this one, there is no problem of the heat up, there is no problem of the damage, blast, everything. So everything will be resolved. Okay, so we have to set a level that if the current will be approaching to this level, after that we have to terminate. That means the output power that is coming from the adapter, that will be not flowing in my mobile.
Okay.
Okay, so that's why the termination point I term is very important. So these three parameter, I fast, I term, and I pre-charge, or I can say the I pre-charge or I minimum. Okay, I think after that professor discuss one charger data sheet. Uh, so you can check this particular data sheet, the BQ24040. That is a LiPo battery charger. LiPo battery charger. I think one cell charger, one cell battery, one cell battery charging subsystem. The professor discussed particularly this data sheet. Okay, I think not more than that cover. Now that's it, I think so, because after that they discuss only the data sheet part.
Okay, sir.
Any doubt now you can ask.
We'll ask in next class, sir.
Okay.
We have to finish labs.
Yeah, sure. So no doubt. Okay, 19th is the last date for week 1 and week 2. Just share the Google form where you have to submit your lab 1 and lab 2. The support team is shared with you or not?
Yes, sir.
Okay. So I think you all are busy in the lab part, so we will wind up if no doubts. Thank you all.
Thank you, sir.
Thank you, sir.
Yes.